Many times when working with a network device, we have traffic that is allowed through and we weren't expecting it to be, or we have traffic that we were expecting to be allowed through that didn't make it. So we might ask ourselves the question, why'd that forward or why'd that fail, aka WTF? And one of the big mysteries in many devices is the default policies that are in place on that system, including implied rules. These are rules that are not explicitly written out, but are still being carried out by the firewall and by the system. So in this nugget, I'd like to walk you through where a lot of those defaults come from and also how we can log those implied rules in the interest of identifying why traffic was forwarded or why it was blocked. So for this demonstration, let's do this. Let's go over to a device over here on the 10.3.00 network. This will represent our branch office. And let's imagine that over here on the left-hand side, we have our headquarters office. And here at our branch office, we can imagine that their default gateway is firewall 2, which is at the IP address of 10.3.0.112. And let's send some traffic from PC2 over to firewall 1 at the IP address of .111 on this same 67.A3.0 network. So the path should be from PC2 to firewall 2 to firewall 1. In fact, on this Windows computer, if we use the command trace RT and we use a -D, which means don't do the name resolution on the way, and we do a trace RT out to 67.83.0.111, and that'll give us some handy information to verify the path that this PC is indeed taking to go ahead and forward traffic across the network. So for this experiment, we're going to start on a computer called DCNUG. And for the moment, I've got DCNUG connected over here. And this network is the 10.3.00 network. And DCNUG's last octet is .100. So DCNUG's address on this network is 10.3.0.100. So let's use the Windows trace RT command and trace over to the .111 address on this 67.83.0 network. So one way to do that is to right-click on the bottom left-hand corner here on DCNUG, right-clicking on that Windows icon, and then from the pop-up, we'll go ahead and click on Command Prompt. And I'm going to resize this a little bit so we can see the topology as this happens. That'll work. And let's use the command traceRT space -D space, and then the IP address of Firewall 1's Ethernet 1 interface on the right-hand side of Firewall 1. Which is 67.A3.0.111. On a Windows computer, behind the scenes, it's actually using ICMP echo requests to facilitate that with a time to live that's being manipulated. So each router in the path sends back a message saying the time to live expired, and that's what's revealing the actual path going from the source to the destination. So not every device, when they do a trace command, uses ICMP. Other devices sometimes use UDP. So it depends on the type of device and the utility you're using as we discover the path through a network. So from this Windows computer over on the 10.3.0 network, we'll do our trace command, press enter, and here it is showing us the path that we expected as shown here and here. Fantastic. Now the big question is, why is that working? And as part of that answer, we can take a look at Smart Console. So let's go back to our management PC. And here on our management PC, which is client-nug in the lab environment, let's go ahead and launch Smart Console. And we'll supply our password for admin, logging onto the management server at 110, and click Login. And here on the Security Policies tab, with the Access Control Policy selected, here we have our security policy. And if we expand these to take a look at the details, we could go through each of these looking for the reason why ICMP was allowed from the PC on the 10.3 network through Firewall 2 and over to Firewall 1. So the parent rule number 1 is traffic from the management PC or the management server. So that's out and all the children are out there. So let's go ahead and collapse that. And let's take a look at rule number 2. We'll expand that. And that's traffic from inside to outside. So that parent matches. In fact, let's rename that real quick because the section title says HQ user traffic, but it really should be any user traffic because we have the inside and outside zones on both firewalls, and this policy is being applied to both firewalls. So we'll go ahead and make that change. And then let's continue looking at the traffic. So from inside to outside, that matches. So we go down to the children. It wasn't DNS, and it wasn't web services. So the ICMP traffic that we sent to the network as part of traceRT is not being permitted as part of the user traffic rules here at all. And then we have a cleanup rule, and that's it. So in this case, what the I mean, how did that traffic go through? Well, another place we could go look to identify why that traffic went through is we could use the Logs and Monitor tab over here on the left. So we'll click on Logs and Monitor. We'll give that a moment to refresh. There's also a refresh button right here that we can use. And then we can analyze and take a look at all this traffic and see if any of it matches. the access rule number 3 in our current policy that's applied is the cleanup rule, which is deleting everything. So everything that matches rule number 3, which is the cleanup rule, is being denied. And that's also being reflected over here as well. So we can skip all those. So there's tons of traffic that's being denied, both by firewall 1 and firewall 2. So what we're looking for is a permit of ICMP. And if we scroll down through this list, I do not see it. I see some IGMP as part of some multicast related traffic. And I see some DNS down here. But I don't see anything in these logs regarding ICMP at all. And if we want to do a search, we could go up here and click in this search field and type in service : ICMP. And we could select ICMP here from the dropdown and then press enter. And that's going to show us everything in this log that is related to ICMP. There's nothing here. It's like, what the heck is going on? And here's the answer to that question. The reason the ICMP is allowed in our lab environment is because we enabled that earlier in our security policy. And it's being implemented as an implied rule. Check this out. If we go up here to the top left and we hover over the menu icon and we click on menu, and then from the drop down, if we go down to global properties and we click on global properties, and then from global properties we select firewall, we enable this option right here, accept ICMP requests, as a global property, and as a result, it got pushed as part of an implied rule across our firewalls. And the question may come up, well, what are some of the other implied rules? And my friend, we are looking at a whole boatload of them right here. So if we want to tweak or modify these rules, we can do so right here as part of the firewall global properties. And the other option that I'd like to introduce right here as well is this bad boy right here. And that is, do you want to log implied rules when they're matched? And for a lab environment, that is fantastic. Or if we're doing some troubleshooting, that is fantastic. Because that way, it will show us in the logs exactly what the heck is going on, including when packets are being permitted or dropped based on any of the implied rules. So let's go ahead and put a check in the checkbox for log implied rules. We'll click OK. We'll go ahead and clear our filter here by clicking that little X. And then we'll click on Publish. We have two changes. We have the change we just made as part of the logging implied rules. We also had a section header change that we changed as part of our security policy. So we'll click on Publish. And then we'll go ahead and click on Install Policy. We'll confirm we want that deployed to both Firewall 1 and Firewall 2. We'll click on Install. And give that just a moment or two to complete. And now that that's done, we can go back and we can test it. Also, as a word of caution, in a production environment where we may have thousands and thousands of packets every minute, which are being denied by implied rules, if we start logging on that in a production environment with lots of traffic, it is going to increase the overhead on the system, and it's also going to consume some additional space as it stores those logs. So now as a test, let's go back to our computer. We're going to use DCNUG for this, which is a device that's sitting over here on the 10.3.0 network. And it logged me out. I'm going to go ahead and supply our lab password and log back in. And then we'll hit the up arrow key in this command prompt and do the same exact traceRT command again over to 67.83.0.111. Press enter. So the output here verifies we're taking the same path. That's great. And now let's go back to our client and take a look at the logs. So back here at Client NUG, the administrative PC, with the logs and monitor tab selected here on the left, and then the logs tab selected on top, we'll go ahead and click on refresh to make sure we're looking at the latest and greatest log information. And let me resize these columns just a little bit. Here it's showing us that Firewall 2 said, yep, that's allowed. The source was 10.3.0.100. That was our client computer at the branch office, going to the destination of 67.83.0.111. And it was an echo request, which is the mechanism that traceRT uses from a Windows computer as part of the traceRT command. In fact, let's go to this first ICMP packet that's being reported by Firewall 2. We'll double click, and then I'm going to bring that full screen by clicking on the Maximize Window button. So the reporting device is Firewall 2. The source was 10.3.0.100. The destination was Firewall 1. It was an ICMP echo request. The policy said go ahead and allow it. And it shows here that it was permitted due to an implied rule. And that's the implied rule that we had in our global properties for Firewall that said please allow ICMP echo requests. But it also shows here that access rule number 2 was matched. So if we click on the tab here called Matched Rules, this is also very interesting. This is showing that the parent rule number 2, which is matching traffic from inside to outside, was matched, However, if we look at the children rules, the inline layers for rule number 2, which would be 2.1 and 2.2, they're permitting HTTP and HTTPS and DNS, not ICMP. But the reason that the ICMP was allowed was due to the implied rule as part of our global policy. And that's why logging that stuff can help us identify why that traffic is being allowed in the first place, and also is a very handy tool in troubleshooting and better understanding the flow of traffic through the gateway. And if we close this log detail window, and if we double click on the permit of that ICMP by Firewall 1 and go to matched rules, from Firewall 1's perspective, this traffic was not sourced from the inside going to the outside from Firewall 1's perspective, and as a result, it didn't even match rule number 2. However, there was still the implied rule that we have as part of our global policy, which says allow ICMP echo requests, which allowed Firewall 1 to accept this ICMP echo request and process it. And one of the great things is that this nugget is associated with a virtual lab. So if you're logged on to the CBT Nuggets website and would like to walk through this exact same scenario along with me, that'll give you the opportunity to reinforce what you are learning with hands-on practice. So if you haven't already, I invite you to do that at your earliest convenience. And if you'd like to practice this a few times, the labs are ready, willing, and able. So enjoy the hands-on. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.